And from 4 to infinity, we just pick x equals 5. Okay, so that gives us 5 plus 2 over 5 minus 1 divided by 5 minus 4 is greater than or equal to 0. So you have 7 times 4 over 1. So 28 over 1, 28 is greater than or equal to 0. It's true. Okay, so this is part of the solution. Okay, and since I'm running out of room here, I'll put the solution interval down there. And we are using greater than or equal to, so that means we're going to use brackets in our solution interval. So we can go from -2 to 1, or remember our 4 is still going to have a parentheses because it can't equal 4. So for this one, you're going to have from 4 to infinity. Because remember, the brackets means that you can include those two numbers. So you can include -2 and positive 1, but you can't include 4. So that's why you have to use the parentheses for that one. Parentheses 4. This was 4, since it can't be used. All right, so any questions on that one? All right. Leave that up for a few seconds. Right. So let's say if you wanted to solve 3 over x minus 1 is less than 2 over x. Right, solution as interval notation. Clean that E up a little bit. Okay. So with this one, you want to once again solve for 0 by bringing everything over to one side, and if possible, make it one fraction. Okay. So you want to simplify. Making it one fraction, which is less than 0. Okay, so if we subtract 2 over x on both sides, that gives us 3 over x minus 1 minus 2 over x is less than 0. Okay, so in order to combine them, we have to give them common denominators. So our 3 over x minus 1 minus 2 over x, we're going to multiply this one by x over x, and this one by x minus 1 over x minus 1, to give them our common denominators. Okay, so that would give us, move that over a little bit, 3 times x, which is 3x. And if we go ahead and distribute our -2, I'll say minus 2, I'll do it on the next step, over x times x minus 1 is less than 0. Now if we distribute the negative 2, we have 3x minus 2x plus 2 over x times x plus 1. Nope, it's less than 0. Okay, so if we go ahead and combine these two, 3x minus 2x is just x. That leaves us with x plus 2 over x times x plus 1 is less than 0. Yes?
What made it plus 1?
Oh, that was just me being negligent. Thank you. Nope, it's plus 2 because we distribute the negative 2. I didn't mess up that many times. Alright, so from there, we know for our numerator to equal 0, x plus 2. Uh-oh, let me kind of separate that a little bit. That gives us our x plus 2 equals 0, which means that x can equal negative 2. We have x equals 0. We might as well put that. Actually, this is our critical number, because that will make our numerator equal 0. And oh, actually, I didn't even. Might as well just made that equal to 0. I'll leave it at that step. And instead of rewriting it, I'll just make that our first step. So change all of those to equal. Save a little bit of space instead of rewriting everything. Yep, there you go. Okay, so we know our denominator can't equal 0. Bring that down just a smidgen. There we go. So that means x can't equal 0 and x can't equal 1. Okay, so that means that x equals 0 and x equals 1 are also critical numbers. Okay, so we put all three of them on our number line. Okay, which is our second and third step. Second step, put them all on the number line. So we have our negative 2, our 0, and our 1. Okay, and we pick our intervals in between them. Okay, so this is negative infinity to negative 2. This is negative 2 to 0. And this is 0 to 1. And this is from 1 to infinity. Okay, so we pick our test values in between each one of those. And from negative infinity to negative 2, we can pick x equals negative 3. Alright, and with this one, it'll probably be easier to plug it into our original inequality instead of where we did all of our alterations. So you have 3 over 3 minus 1 is less than 2 over negative 3. Okay, so you have 3 over 2 is less than 2 over negative 3. So you have a positive number being less than a negative number, which is false. Oh, let me make sure, negative 3, negative 3. Nope, actually, negative 3, I put 3 for some reason, so this should be negative 4. Sorry about that. Okay, so you have negative 3/4, which is negative 0.75, and you have negative 2/3, which is negative 0.66. So if you drew them on a number line, negative 3/4 would be here, and negative 2/3 would be here. So negative 3/4 actually is less than negative 2/3. So this is true. Okay. So now we pick on the interval from negative 2 to 0. And in this case, we can't pick 0, so we have to pick something else. So we can pick negative 1. Okay, so if we pick negative 1, we have 3 over negative 1 minus 1 is less than 2 over negative 1. Okay, so you have 3 over negative 2, or negative 3 over 2, is less than negative 2. Okay, so negative 3 over 2 is negative 1.5. Okay, so you have negative 3 over 2, and negative 2 is here. So negative 2 is actually less than negative 3 over 2, so this is false. Okay, so we know it's not part. And this one is, let me mark that. Okay. So between 0 and 1, you can pick 0.5 or 1/2. Okay, so we have 3 over, we'll make 0.5 equals 0.5. So you have 0.5 minus 1 is less than 2 over 0.5. Okay. So here we have 3 over negative 1/2, or negative 0.5, which is less than 2 over 0.5. Okay. So you have a negative, which is less than a positive, which is true. Oh, let me write that out. Negative less than a positive, which is true. Okay. So we know that this is part of our solution. Okay. And for 1 to infinity, you can pick x equals 2. Okay. So that gives us 3 over 2 minus 1 is less than 2 over 2. So that comes to 3 over 1 is less than 1. So 3 is less than 1 is false. Make sure. Yeah. Okay, so this is not part of the solution. All right, so let me cross that out. That means our solution interval, bring that up a little. Here we go. Will be from negative infinity to negative 2. And remember, we're only using less than, so we're going to have parentheses. Negative infinity to negative 2. Or from 0 to 1. Yep. And if you wanted to graph it, which you don't have to, but in case you just want to burn a little extra time, from negative 2 to negative infinity, or from 1 to infinity. Oh, 0 to 1. Why did I put 1 to infinity? I think all the rest of them had infinity, so I just automatically went to infinity. Zero to 1. There we go. All right, so any questions on that one? All right. Okay, so this next example is just a little bit different. Want to make sure you saw this in case you ran across one like it. So you want to solve 1 over x squared plus 7x plus 12 is greater than or equal to 0. Oh, there we go. And you want to write as interval notation. Now with this one, you can't put it in standard form because if you multiply both sides by this, it would just become 0. And your numerator will never ever equal 0. 1 is just not going to equal 0. So you won't have a critical point for your numerator equaling 0. So you will have critical points for your denominator equaling 0. Okay, so in this case, you'll have just the 2 critical points for the denominator. Okay, so that means 1 over x squared plus 7x plus 12. Do our first step. Make that equal to 0. That factors out to become 1 over x plus 3 times x plus 4 is equal to 0. Okay. Like I said before, 1 will never equal 0 since the numerator 1 will never equal 0. The denominator will give the only critical points. Okay, so for all the rest of them, we just had a numerator that equals 0 and denominator, but on this one, we just have to pick the one. Okay, so that means x plus 3 equals 0, or x equals -3, and x plus 4 equals 0, or x equals -4. Will be our only critical points. So we can go ahead and do our second and third step. Okay, so we put -3 and -4. -4 actually comes before it. Clean that up a little. All right, so that means we have the interval from, bring that up some, -infinity to -4. We have from -4 to -3. And we have from -3 to positive infinity. Okay, so for this one, we can pick x equals -5. All right, and remember, we can always get this and factor it to this being greater than or equal to 0. I'll put that over here. So we can use 1 over x plus 3 times x plus 4 is greater than or equal to 0. Okay, so if we plug in negative 5, I have 1 over negative 5 plus 3 over negative 5 plus 4 is greater than or equal to 0. Negative 5 plus 3 give you 1 over negative 2 times negative 1 greater than or equal to 0, which gives you 1/2 is greater than or equal to 0, which is true. Okay, so this is part of the solution. Uh-oh. Okay, so between negative 4 and negative 3, you can pick x equals negative 3.5. Okay. So that gives you 1 over negative 3.5 plus 3 and negative 3.5 plus 4 is greater than or equal to 0. Okay, so negative 3.5, and this is where you don't have to worry about actually solving it. You have 1. Negative 3.5 minus 3 will give you a negative number. Negative 3.5 plus 4, since 4 is bigger, that will give you a positive number. It is greater than or equal to 0, so a negative times a positive is negative. So this is actually a negative number. It's greater than or equal to 0, which is false. So we can go ahead and cross that out. Okay, so from 3 to infinity, we can pick x equals 0, or negative 3 to infinity. Okay, so that would give us 1 over 0 plus 3 times 0 plus 4 is greater than or equal to 0, which is 1/12 is greater than or equal to 0, which is true. Okay, so this is part of the solution. Oh, separate that a little bit. Okay, so that means our solution interval will actually be from negative 4, and remember it's greater than or equal to, but we're going to have to use parentheses for those, even though it's greater than or equal to, simply because if we put in negative 4, it will make the denominator 0. If we put in negative 3, it will make the denominator 0. So you have negative infinity to negative 4, or from negative 3 to infinity. Make that a little side note. Parentheses used since x equals negative 4 and x equals negative 3. We'll make the denominator equals 0. All right, so any questions on that one? All right. Okay, so we'll do one story problem, and that'll probably be it for today. Oh, let's do writing. All right. Everybody got that? Yep, looks like everybody's done. Oh, might as well restart it since it's going to shut off in 6 minutes anyway.